think I was a bit lucky to be the one to continue after Wolfgang's slightly futuristic presentation from Koyan. He comes from a different world than ours. We are now today, in my session, talking about odd form assembly, and when you hear odd form, it really means odd form. And we are facing very hands-on problems. But fortunately, we Finns are familiar with that. So from my point of view, the world Wolfgang was describing, it ends here. And after that, you are in the wilderness. Fortunately, Cencorp comes from the wilderness. We live in Finland, we eat what we can catch. And we don't get stuff delivered by robots from the from any supermarket chain or whatever fast food delivery. We have to catch what we eat on our own. So, Cencorp, we do odd form assembly machines. We have all the feeders necessary to feed the components. We do the paneling systems, and we do some production automation, pick and pack solution, test handling solution, lasers and software combined with any of these two key processes. And our world is very different. Here is a typical example when we focus now on through-hole assembly. We deliver systems for many industrial segments, and typically we can do everything from single cells to complete lines, and really our focus is to be as flexible as possible in this very tough environment. We can provide solutions, I will explain more, with full track and trace and statistical analysis of the process. And this will help. But we have to start with some basic facts. We can place almost any component. The problem is that the component have legs, and the tolerances are in most cases poor, and the legs need to go into the holes, and it doesn't matter how much artificial intelligence you put behind this. If the legs are not according to tolerance, your placement process will not succeed. So when we automate the odd form business, it always requires cooperation between supplier and our customer and the component suppliers of our customers. We live in a world where there is a huge shortage of components, meaning most of you are facing daily battles to get components sourced to keep your production running. And it means you are sourcing wherever you get components, and packages, well, that's a secondary issue. You want the component, but if you want a stable odd form process, you must have the supply of the components under control. And this is, as I said, it requires cooperation between machine supplier and customer, and also your customer, your component supplier. It is hard work, but after that you can enjoy a very stable process actually. And why should you automate? Well, this is really simple basic facts. You can get better quality, you can get higher capacity, and you can improve your process, and the floor space is reduced compared to having manual lines with 20 operators placing parts manually, and you have no control of the quality that they are producing, unless you then have an inspection system afterwards, but then it's normally too late. But typical challenges that we see is, of course, that, as I said, there are very big issues on the on the component supply, on the packaging material. But there is also from our side always a solution if this is planned well in advance. I will not go into details, I have very limited time today. The platform is still not the key driver here. Pick and place machines, yes, you need to inspect components before placement, yes, but everything in the final end comes down to how you hold the component, how it's presented to the machine. And we are with different platforms at a different cycle time rate at the moment. We are not the fastest, but we can definitely handle everything you throw at us. But when things get challenging, we are working today with world-leading customers producing inverters, soft starters, and they are running a huge amount of component variants and also a huge amount of product variants. And we have tools today that when we put a production line with 4 to 5 to 6 cells after each other, we have tools to produce batch size 1, which is quite remarkable in this field. And things look easy on the general level, but I think there is one magic word here, that when you have hundreds of different product variants and you have hundreds of components, we can deliver turnkey lines where all components are available in the line all the time. There is no changeover. So we scan the barcode of the product and we can produce whatever is thrown at the line. We have systems where we have direct communication from the customer's engineering tools. So when they are designing the product, they are actually defining also clinching parameters for our components. So I can have a production line with 4 machines and they are running one product program in the machine, and still we can produce all the variants available. We get the placement data directly from the ERP system, including all component handling processes. And to maintain this kind of line, it becomes so much easier, because comparing to a solution where you would have 5 machines and product specific placement programs for every single product, you have hundreds of programs to maintain in the line. And now in this case you have one program, and it's actually maintained by the engineers of our customers when they are defining the BOM of the product. So to keep the production process stable, this is totally different than going in and teaching something new. And actually introducing a new product to this line is automatic as long as the components used on the product are known to the line. So if I have a feeder in the line, I don't even need to make a program when we introduce a new product. Everything comes again directly from the CAD data system of the customer. And if there is a new component introduced, then of course I need to place a new feeder for the component, and I need to teach the pick position for this component, but everything else is then handled automatically. And this is one of the tools we are using to extend the feeder capacity of our machines. So this is, of course, this is not for everybody and it's not necessary for everybody, but when I have a customer with hundreds of components, I can increase by having these special intelligent component handling solutions, we can exceed or increase the feeding capacity with up to 20-25 feeders compared to the standard machine. And I'm able inside this pre-handling machine also to handle different board thicknesses. So if we are running different board thicknesses in the line, and in a traditional on-form system, we are always cutting the component legs in the feeder to a specific length. But when the board is thin, you have slightly too long legs, and when they are clinched, there is a risk for short circuit after soldering. But with this kind of solution, I can cut according to the actual board that is in the machine. And this is done in real time, online, and when the board arrives on the PCB conveyor, I'm of course scanning it here on the buffer place, and I can tell this machine that, okay, for the next set of components you are feeding, they need to be 0.5 millimeter shorter. We are also doing oversized on-form component placement. As you know, capacitors and the use of large capacitors is increasing again for batteries and different sources on the power electronics side. And we have created this kind of very customized solution together with one of our key customers, and we use the knowledge of KUKA robotics, but actually KUKA robotics is only providing the arm and the basic software for the robot arm, and we have put the Cencorp on-form software on top of this solution so that we can again run this batch size 1 production pattern. Panels arriving on a conveyor, we are reading what is going to be placed before, and the robot arm is picking the correct capacitor of each type. We are using camera system to inspect the position, because the picking position is of course undefined when they arrive in cardboard boxes, and they can be rotated, so we need to identify the direction of the component, and we need to define the actual position before picking, and we are using camera on the robot arm and camera before the placement. And we are also having in this head, we are having a force sensor provided by KUKA to detect that the placement process is stable. And one of the key drivers also from our customer in this case was really to help on the ergonomics for the operators. Imagine working with this, placing this by hand, using the force 8 hours per day. It is very, very heavy on the arms, and this has now been completely solved with this RoboBox solution. But again, I want to emphasize the maximum flexibility. This is still, compared to how many of the competitors in the on-form field coming from the SMT side, they want to use multiple heads, and they have some of them don't have clinching units. We have, I think, the most sophisticated clinching unit on the market, with of course force detection on the clinching. But this is the key to the process, to a stable on-form process, that you know what you are holding. And this is a very good example actually of where I started. You have a component with very poor lead to body tolerance, and you need to know after picking that where are the legs actually located. But unfortunately, to be efficient on the on-form side, yes, the machine can detect and place according to the best position for all the legs in the component. But if you are out of spec, what can the machine do? It can throw the component away and pick a next one. And you can of course maintain that if your fail rate is low, but especially coils like this. There are also other type of coils, of course, with even more stiff copper leads that we are placing, where the tolerances are much poorer, and the only way is to go back to the component supplier and find a way to make the components and the holes in the PCBs match with the actual tolerance of the component legs. But coming back to the process, so we are picking parts from the feeders, we have component presence detection, we have collision detection, and we have a program about pushing pin. So in this case it's not needed, but when we are placing axial components, we are using the pusher to press the component through the board. And everything is fully programmable, and all the parameters can be monitored. I have another good example. You see a capacitor here. This is very critical. It seems like an easy process to place a capacitor, but we had customers facing huge recalls from another competitor machines because they were holding the capacitor slightly too hard, and after a while they broke in the field and they had to recall a lot of products. And we have what we call the sensitive gripping that enables using different gripping force depending on the component we are handling, and we have force measurement tools that can be integrated into the machine. So in regular intervals we are going to check that the force produced by the servo gripper is stable, and thereby we can have what also Wolfgang was talking about, self-diagnostics of the machine, that it knows that it's keeping the process under control. Okay, yeah, one more thing. As we are focusing on big components, we can place everything from small through-hole components to the big ones I showed you. But this is also a quite unique feature, because in the clinching unit, it's not shown on this picture, we can have a second snap fit component support. So we can place with this 1500 odd form platform, we can place semi-press fit components with forces up to 500 newtons. And this has proven a very useful feature, and we are seeing more and more needs. We are placing metal shields, which is not actually a electronic components, it's just a Faraday cage on top of other components on the board, and they need to be pressed and they need to be seated, and some snapping clips need to be go through the board and lock on the other side. So this is a really good additional feature from our machines. But coming back to the full process control, on top of the Orform machine, of course, we want to provide different software tools, and they are server-based, and normally you have one line server in the factory, and we can connect. In some factories we have up to 45 or 50 of the Cencorp machines, and they are communicating with the same production database, and you can get statistics of the process. You can analyze that, okay, during the morning shift I had surprisingly many stops from this component, and then you can go into details and check what has happened and what is the root cause. And the traceability systems, this is more and more important, of course. So when you are filling components to the feeders, we use handheld barcode readers that are communicating with the line control system, verifying that the operator is not able to place the wrong component type into a feeder. It is also keeping batch data, of course, so that when you are refilling the feeder, we know that, okay, batch 1 ends and we have a second batch of components, or if later on there is a problem on the component, you know what products have that certain batch included. And currently on these PDAs that we are using, we are also adding more information to the screen. So when you have a line operator that is responsible for filling the line with feeders, you can also get on the user interface of the PDA, it will tell you that, okay, after 3 minutes feeder number 10 on machine number 2 will run out of components, and it tells you that, okay, time to prepare with more material. Yeah. So I would say from my side, this was an extremely fast overview. I tried to keep the schedule, and I'm here today. Matthew is handling the sales of our equipment here in the UK and Ireland, and you can discuss the process with him. Today I had no time to talk about the depaneling. This is the second product portfolio that we are producing, and there it's also, of course, equally important for us, and I'm happy to take questions later on, and happy to come on site also if you want to discuss further. So from my side, I'm happy. Thank you.